Hello everyone, my name is Rafael Brito. I'm here today to talk about my final project at the Deep Learning course at Harvard Extension School. And the topic that I chose was credit card fraud detection. And I chose to compare two solutions. One, a simple neural network that we learned from the course, and comparing to a cloud service, a new service from Google called AutoML. So let's talk about GCP AutoML first. This is a service in beta that Google came up with that, and it claims to train, create, and deploy a machine learning model without any effort and without any expertise. And the cost for this service is $19.32 per hour. And why they came up with this? So here's the problem statement, the business problem statement. Businesses and corporations, they need to incorporate machine learning in their portfolio. And credit card fraud, it's a lot of competition in the banking industry. So this service will provide time to market to those corporations to take advantage of machine learning. Now, the question is how good those models created automatically for you are efficient. So that's the case study for this paper, comparing the homegrown solution using Keras in a simple network and AutoML. So let's talk about the data set, the credit card fraud data set. It's a public data set with 150 megs as a CSV file uncompressed. It's around 284,000 transactions. And the data set has around 30 columns, and the features are, for confidentiality purposes, they're labeled V1, V2, V3, and so on, up to V28. And they're normalized. The only two columns that are not normalized are time, which is seconds after a given point in time, and amount, which is the amount of the transaction. Now, here's the catch about this data set. Like any fraud data set, it's very imbalanced. What does it mean? Only a small fraction of the sample are flagged as positive. In this case, it's only 0.172% of 280,000 entries are classified as a fraud. So when you work with imbalanced data set, I put the link on the screen. It's a chapter, a book. Two things. One is create a subsample for training with the 50-50% ratio of what you want to train for. In this case, it's 50% of fraud and 50% of non-fraud. And a key metric for fraud and imbalanced data set is the confusion matrix, which I put here on the screen. Basically, it's a matrix to determine the number of true negative, the false positive, the false negative, and true positive of the sample. And that's going to be the metric we're going to use to compare the two solutions, the simple neural network and AutoML. Right, let's move on. So first, on the simple neural net, I did some pre-processing of the data set. As I mentioned, I need to scale the amount and time columns, and I create the what I call undersample of the subset of the sample for the training. And here I show the distribution of the subsample for the training. Before I create the model, I did some interpretation of the data using Seaborn to see which features are correlated to the class, meaning the class is the target, which is 0 for no fraud and 1 for fraud. And here show the correlation matrix. Now, the lessons learned is you need to do the correlation with the undersample, with the sample you created with 50-50. Otherwise, your correlation going to be off. So as you can see here, the V17, V14, V12 are negatively correlated with the fraud, and V2, V4, V11 are positive correlated. Then created the simple network, and as a reference, I used one of the top kernels of Kaggle as inspiration and reference. So it's a very simple network with 3 dense layers. And since the training sample is only around 1,000 transactions, was extremely fast to train. It took seconds. And here's the result. We have accuracy about 0.94, and here's the confusion matrix, where here we're gonna see in red the good transactions, like no fraud, and here is the false positive, okay, which is 4.5%. That means that the model predicted that was a fraud, but in reality was not. And in the bottom is the fraud occurrences. Here 94, when the model correctly predicted that was a fraud, and it was a fraud. And here is where the model said it was not a fraud, but actually it was a fraud, which is a false negative, which is 4%. So that's the simple neural network numbers. Now I'm gonna move on to the AutoML. Okay, so before I go to this screen, I'm gonna show actually how it looks like on the Google Cloud Platform. And the first step that I did using AutoML was actually uploading the data, and I use BigQuery for that. I'm gonna show here on the screen. This is the Google Cloud Platform. You can create your login. They give $300 for the first year, and each service has their own billing. And over here, what you see on the screen is BigQuery. Basically, you upload your CSV file. I did upload the CSV file as is on BigQuery. And here you're gonna see the data come in, the data, the schema, and the details. Okay, I just uploaded as is. And the funny thing about BigQuery, you can do whatever you want on the top part as an SQL, and even create models, but it's not what we're gonna talk about. Just another add-on, just to show how Google is investing a lot on machine learning services. Right, so I uploaded my data. I have my data here showing up, the size and so on. The second step is actually you go to the AutoML, and you're gonna import the data to AutoML. This is a very simple step because it just pointed to my BigQuery data. There's nothing much to do besides just pointing to the BigQuery and using the project ID, the dataset ID, or whatever. And then let me show you this is the AutoML workflow, and then here where you import the data. The data came from my Google Drive, but you can put it in a bucket and stuff like this. Right. The second step is really to determine the schema, and the AutoML find out the columns you want, and the very important part is which column you're gonna flag as a target. In this case, is class 0 for known fraud and 1 for fraud, and that's when you tell which target for prediction. That's the step number 3. Then step number 4, when AutoML gonna do some analysis of your data, and when you click here, for me it took 30 minutes, and it gives all the standard statistical data about your information. And the cool thing here, when you click on class, it gives the distribution as is, here how imbalanced the data is, and the correlated features for this. Those are the variables, which is the first flaw that I saw in AutoML, that they did on the entire sample. They didn't figure out that was an imbalanced data, and the values here are different from the neural network that I created, which is the neural network is correct one, this is the incorrect one. So the first problem that I saw with the AutoML. So if I have to be a product manager, I'll tell them they need to figure out that same balance data set, and then they need to act accordingly. Right. The other step is to train. So when you click here, it's going to start to train and create your model. For me, it took 5 hours. The first 6 hours for free, so you're not paying $20 per hour. This is an additional of a $300 credit that one has. So I got a note, an email in the middle of the night saying that the model was done. So here it tells all the model is look like. Then you click here, you're gonna see the full evaluation, all the metrics, and what columns you use, accuracy. One key score is F1 score for imbalanced data. Unfortunately, I don't have this score for Keras because Keras dropped it in the recent version. But this is a good score to look at. And the key here is the confusion matrix, which is the same metric I'm using to compare with my neural network. Okay. Here's the same screenshot that I took and showed to you guys. And here's the conclusion, right? The Google AutoML was better for false positives. Remember again that I just uploaded the data set as is. It didn't do any pre-processing of the data set. Now, the simple neural network was better on false negative, much better, 4% versus 23%. So for both solutions, there's a lot of space, a lot of room for improvement. On AutoML, if I upload my subsample with 50% for fraud to do the training, I guarantee you'll get much better results on AutoML. And on my single neural network, I could use other techniques like SMOT or any more elaborate network models to come up with a bigger accuracy. The net of this study is the Google AutoML was really acceptable for corporations that have zero understanding of machine learning and was pretty plug and play to start to use the machine learning on their businesses. As a bonus, they're going to show you the other feature of AutoML that actually you can deploy and use your model immediately after the training. So if I come over here and click predict, you can upload another set of data and it's going to predict for you based on this model. And they created a RESTful microservice API, and I'm going to show you here. Once you create the model and you decide to export the model, you create your data that you want to request. In this case, I put in a JSON file. Here's an entry with a single row. You can create as many rows you want with all the variables, all the features, amount, the amount here, the time here, and then I come and I invoke regular curl, which is a RESTful API, and it's gonna go to my model here. Here's my information about my model and so on, and it will execute and return to you. So let me run this guy. So I upload this and it's taking the time and return that with the score. So in this particular entry, it's 99.99% for non-fraud and very small for fraud. And it took 3 seconds just to execute this. So I can, right now, my model is deployed on the network, on the internet, and anyone can use it as long as it has access. All right. That's all for today. Thanks for watching and have a great summer. Bye.